Hi everyone, I'm Lim Yang Yao from Despa College. Today, me and my teammate will present about the shear force. And before we start our topic, let my teammate introduce themselves.
Hi guys, I'm Kumin Shi from Despak College.
Hello, how are you? My name is Terence. My nickname is Abang Ter. I'm from Despak College.
Hi, my name is Lee Shunjing from DAET KC1.
Hello guys, I'm Teng Zichen from Despak College.
Hi everyone, I am Patrick Lee Pei Fong from Despak College.
Hi everyone, I'm Tae Minh Nguyen from Despak College.
So let's move on to our topic.
Introduction. The focus topic is stress, where we need to conduct an experiment to identify the relationship between the shearing stress of steel rulers and weight, using equipment such as clamps, steel rulers, and weight steel. Objective. The objective for lab report 2 is to measure how shear force varies with rising point load. Construct the table and plot the graph.
Theory. Shear stress is the force applied to the unit area of the member, while the shear force is the force acting on any part of the normal beam to the axis. As for the result, to measure using the formula, tangent angular displacement equals to total displacement over total length.
Additional theory. Shearing force are non-aligned force that move one part of the body in a particular direction and another part of the body in the opposite direction. Besides that, when the forces are related to each other, they call the powers of compression. Such an example, a deck of cards is being pushed and at two directions, causing the card to slide.
Procedure. First, prepare all the material. Second, use a hammer to knock the nail on the wooden board. Third, use a ruler to measure the inertia. Fourth, fill up the water into a bottle according to the weight. Fifth, hang the bottle on the nail. Sixth, use the ruler to measure the diameter for the nail. 7. Repeat the step 4 to 6 to get the result. Let's watch the video for the procedure.
As a result of our experiment, we have weights from 400 gram to 2,400 gram. And for 400 gram, we have angular displacement of 16.48. And for 800 gram, we got 16.47. For 1,200 gram, we got angular displacement of 16.45. And 1,600 gram, we got angular displacement of 16.43. 2,000 gram, we got angular displacement of 16.42. And 2,400 gram, we got angular displacement of 16.4. So the shearing force, there's a graph which has a positive correlation. And this graph shows the weight to angular displacement. As a discussion question, for the first question, comments on the shape of the graph. What does it tell us about how shear force varies due to an increased load? Does the equation we use accurately predict the behavior of the beam? From the graph, it shows that the relationship between the load and shear force is directly proportional. Means that the value of shear force increase when the load that has been placed increase. The equation that was used in this experiment calculations accurately predicts the behavior of the beam.
Discussion number 2, comment on how the result of the experiments compare with those calculated using the theoretical. There is a difference between the experimental and theoretical results. This may have happened due to some errors, such as the sensitive apparatus being easily affected by its surroundings. This is also may have caused by the apparatus that is not calibrated or maintenance for a long time, hence there will be an error, which is the reading will be slightly different from the actual reading. The next one. Okay, answering the question number 1, the new value for total displacement is 18 cm. Find the new angular displacement in cm. So the formula is tangent times angular displacement equals to total displacement times length. So the first step is 18 times 2.5 equals to 45. So then you can find the angular displacement. The answer is, the new angular displacement is 88.727 cm.
Okay, there is second question in this report. What is the application for the shearing stress in the automotive system? There are many applications for the shearing stress in automotive systems. For instance, the drive shaft of a standard rear-wheel drive automobile depicted in Figure 1 serves primarily to transmit torsion. These shafts are almost always hollow and circulate in cross-section, transmitting power from the transmission to the differentiation joint, at which the rotation is diverted to the drive wheels. As in the case of pressure vessels, it is important to be aware of design maintenance for such structures purely for their inherent usefulness. However, we study them here also because they illustrate the role of shearing stress and strains. As the figure one is the drive shaft. Shear stress in the shaft, the theory of shear stress in the shaft, when a shaft is subjected to a torque or twisting, in a shearing stress is produced in the shaft. The shear stress varies from 0 in the axis to a maximum at the outside surface of the shaft.
Conclusion: we are able to determine from this experiment how shear force varies with an increasing point load. The shear force at the beam cutting position from different load condition was also observed. It can be inferred from this laboratory experiment that the shear force will also increase as the load we put on the beam increase. Shear force at the cutting section has been shown to match the force working both right and right of the cutting section on the plate.